Welcome to day 10 of our object-oriented programming course. Today we will dive into the concept of abstraction, one of the core principles of O. We will explore what abstraction is, its types, and how it helps simplify complex systems. Let's begin. At its core, abstraction is the process of hiding the complex details of a system and exposing only the essential features. It allows you to build on high-level functionalities without getting bogged down by low-level implementation details. Think of it as using a remote control without needing to understand the circuits inside. A real-world example of abstraction is driving a car. When you drive, you don't need to know how the engine or transmission works. You just interact with the steering wheel, pedals, and controls. This is abstraction in action. You are interacting with a simple interface while the complex details are hidden. In object-oriented programming, there are two main types of abstraction: abstract classes and interfaces. Let's understand both in detail. An abstract class is a class that cannot be instantiated on its own. It can have both abstract methods, which must be implemented by subclasses, and concrete methods, which have a default implementation. This is useful when we want to provide a common base class with some default functionality while still enforcing specific implementations in derived classes. Here's an example of an abstract class in Java. We define an abstract class called shape with an abstract method draw. This method will be implemented by the derived classes such as circle or square, while the base class shape must also have concrete methods like move that can be inherited directly. Let's take a look at how we implement abstract classes. In this example, we have two derived classes, circle and square, both of which override the draw method to provide specific implementations. The shape class defines the structure, but it's the subclasses that provide the detailed behavior. Next, let's talk about interfaces. An interface defines a contract of behavior. Unlike abstract classes, interfaces don't provide any implementation. Any class that implements an interface must provide the behavior specified in the interface. This is useful when you need to enforce a specific set of methods across different classes without tying them to a common ancestor. Here's an example of an interface in Java. The drawable interface has a method draw, and the classes circle and square implement this interface, providing their own draw method implementations. This way, the behavior is defined by the interface but implemented by the individual classes. Now let's compare abstract classes and interfaces. Abstract classes can have both abstract and concrete methods, and they allow you to provide default implementations. On the other hand, interfaces define a contract for behavior, but the implementing classes must provide all method implementations. You can think of abstract classes as providing a blueprint, while interfaces provide a promise of behavior. So, when should you use an abstract class, and When should you use an interface? If you have related classes that share common behavior, an abstract class is a good choice. If you need to define a common set of operations for unrelated classes, then an interface is more appropriate. Let's move on to an exercise. Your task is to create an abstract class called shape with an abstract method draw. Then create two derived classes, circle and rectangle, and implement the draw method in both classes. This will help you understand how abstraction simplifies your code and enforces structure. In summary, abstraction allows us to focus on the essential details and hide the complexity behind simpler interfaces. We can achieve abstraction through abstract classes and interfaces, both of which help structure our code in a way that is modular, flexible, and easy to maintain. That wraps up our session on abstraction. Make sure to practice the concepts we have covered today, as they are foundational to understanding OOP. Join us tomorrow for day 11, where we will dive into polymorphism. Thank you for your attention.